Granta Selector is an incredibly powerful material selection tool as part of the Ansys suite. In addition to an extensive catalog of materials and material properties, Granta Selector also contains auxiliary tools such as an engineering solver to quickly identify mechanical constraints, the eco audit tool to comprehensively understand the environmental impact of a product, and a material synthesizer tool to design battery modules, composites, as well as cellular and multi-layered structures. In this video, we will explore the workflow of picking the best material for a model undergoing a standard loading condition using the engineering solver tool. To begin, let's overview our loading condition of a simply supported I-beam with a uniformly distributed load of 1000 newtons across its length. Granta Selector can be opened through either Ansys Workbench or as a standalone software, as shown in this tutorial using the Windows search bar. Once open, click Continue and select the Metals Plus database. From there, select Solver to open up the engineering solver. Here, we can see the various situations that we can analyze and convert from loading into mechanical property requirements. For our analysis, pick Beam in Bending. Next, we can change the cross-section of the beam to an I-section and copy over our geometry description. We can then expand the loading conditions to see the list of available options to choose from within this particular loading situation. The constrained and free pivot uniformly distributed load is appropriate for our analysis. Finally, fill in the load, desired safety factor, and maximum acceptable deflection. The engineering solver tool will then provide mechanical requirements in the form of minimum Young's modulus and minimum yield strength. Back in the main Granta Selector screen, change to the Chart Select tool and choose All Material in Material Universe as the sub-selection. Then add in a limit and transfer over the requirements from the engineering solver under Mechanical Properties. Then click Apply to set the filter. We can then add in a price and a density constraint as well to further filter the remaining materials. Finally, we can add in a chart to visualize the environmental impact of the remaining materials by plotting the amount of CO2 generated during production. Then, using the Box Select tool, we can further filter the remaining materials to pick the ones with the lowest CO2 emissions. Then, under the Results section, the materials can be ranked based off any of the selected parameters. Using price as an example, ranking by price brings up the materials with the lowest cost per kilogram. From here, the desired materials can be compared against each other in a comparison table to finally pick the optimal material for the project.